All right, we have 5.5. 5.5, we're going to solve a quadratic. Now, we've already solved a quadratic by factoring, but sometimes factoring doesn't work. So this time we're going to solve a quadratic by completing the square. Now, keep in mind, we are working from the general form, ax squared plus bx plus c, and it has to equal 0. There is no option on this. It has to equal 0, or we cannot solve or move forward or factor, or complete the square, or even later do the quadratic formula. All right. So first of all, we have many steps to this. So we're going to get through the steps, and then we're going to apply it to some examples. So the very first step that we need to do, step 1, is that when we complete the square, the coefficient of the x squared, meaning the a, must be 1. If so, move to the next step. If not, divide all terms by the a. All right, step 2. We need to isolate the variables by moving the constant to the other side of the equal sign. Now this is where we're going to get a little bit trickier, so just make sure that you get the notes down. Then we're going to apply these notes to the examples, but you need to get the steps down. Step number 3 is we're going to take the middle coefficient, which is the b, and divide it by 2. And it's always divided by 2. Step 4, whatever answer we got in 3, square it. So whatever we divided by 2, whatever that answer is, we're going to square it. Step 5, we're going to add that square from step 4 to both sides of the equal sign that we now have in that came from step 2. Back up here after we moved the constant. The 6th is that we're going to factor the left side into a perfect square. What that means is that we're going to be able to get the same factor here, and it's going to be able to be written as a quantity squared. Step number 7, because I now have a quantity squared and I'm solving, I'm now going to square root both sides. Remember, when I square root, I get two answers, one positive and one negative. And then number 8, last step, solve for the variable. All right, so it sounds like a lot, but hopefully after we do a few examples, you're going to see that it gets a little bit better, a little bit easier for us. But I know might be the first time we're seeing it. It does require you using your notes and following it through until you get better at it. So let's take our notes and we're going to apply it to some examples here. First one, x squared plus 6x plus 5. Now, you should be able to go, oh, well, if I saw this on a normal day before today, you would have factored this into x plus 5, x plus 1, and you would have said, oh, x is negative 5 and negative 1. Not everything is factorable. So we're going to try this example with complete the square. So because we know what we should be getting, let's make sure that we can apply our 8 steps to what, and hopefully what we consider an easier problem. Okay, so first of all, the coefficient of x squared must be 1, and it is. So, yay, that is done. Step 2, it says we're going to isolate the variables by moving the constant. So the 5 is the constant. If I move that, I get negative 5. Step 3. Step 3 says we're going to take the middle coefficient of b. So b is the 6. We're going to divide it by 2 and get 3. Step 4 says whatever we got when we divided, square it. Step 5 says we're going to take what we got when we squared it, and we're going to add it to both sides of what we did here in step 2. So we're going to add it to both sides. So we get x squared plus 6x, and it's always add, plus 9 equal to negative 5 plus 9. So notice, there it is. It's step 5. It's added to both sides. Then it says on step 6, we're going to be able to factor this into the same pieces, x and x, and 9 will give me 3 and 3, plus and plus. The reality is that number that we put here, so this becomes x plus 3 squared. The number we put here will always, always, always come from step 3. Will always come from whatever we got when we divided by 2. That's the number that's going to go in there. So it doesn't matter if it comes out to be ugly, a fraction, whatever. It's always going to be what we got when we divided by 2. And then we can combine negative 5 and 9. So step 7, we have a square, so we're going to square root both sides. A square and a square root cancel, so x plus 3 is plus minus 2, square root of 4. So 8 means move the 3, because we're going to solve for the x. So x is minus 3 plus or minus 2. And we should know that minus 3 plus 2 is minus 1. And minus 3 minus 2 is negative 5. Which is what we would have came up with if we factored it. Again, this was an easy problem that we know we could factor. We knew what our numbers were going to come out to be. So that's what we wanted to start with by practicing. Make sure that we can get the same answer to an easy one, so that when the difficult ones come by, we're a little bit more confident with it. Okay, so let's try one that's a little bit more difficult. All right, we're going to have 3x squared plus 12x equals 9. All right. So our coefficient of x squared must be 1. So step 1 means I need to divide everything by the 3. So I'm going to get x squared for x equals 3. Step 2 says isolate the variables, so the constant's on the other side. Well, that was by default because of the way the problem was written, so that one's okay. Step 3, the middle coefficient divided by 2. Step 4 says square it. Step 5 says we need to add it to both sides. Step 6 says we're going to get a perfect square. That square always comes from step 3. Step 7 says square root both sides, and when you square square root, the only thing that's left standing is what's inside. We get 2 answers and the square root of 7. And solve for our x. Move over the 2 means we get negative 2 plus minus root 7. And you can leave it that way. You do not need to separate it into negative 2 plus root 7, negative 2 minus root 7. You do not have to do this. You can if you like, but you don't have to. You're welcome to leave it just as negative 2 plus minus root 7. Okay. Try it again. X squared, x plus 1. I highly recommend at this point that you pause the video, try it on your own, and then come back and see the steps that I did to see if you match up. So pause and come back. First thing you want to do is you want to make sure that we have everything in the right order. So x squared minus x. Now my leading coefficient is a 1, so that's okay. Step 2, I have moved the constant over, so that's good. Step 3 says I take the middle term and divide it by 2, so I get negative 1/2. Step 4 says I square that, so that's going to give me a positive 1/4. Step 5 says I'm going to add that to both sides of my equal sign. Step 6 says it's going to give me a perfect square. I do not care that it's a fraction. I know that it's going to be whatever it is I got in step 3. It doesn't matter that it's a fraction. Whatever I got in step 3 when I divided by 2 is what's going to go there, including the sign. And 1 1/4 is 5/4 because we do not use mixed numbers and we do not use decimals. Square root both sides, so x minus 1/2 is plus minus, and when I square root 5/4, I get the square root of 5 over 2, because 5 can't be simplified and square root of 4 is 2. And now I'm going to move over last step, number 8, by adding the 1/2. I get 1/2 plus minus root 5 over 2. And that's good enough. You do not have to combine that together, move it, whatever. It is fine just the way it is. All right, last one. X squared minus 4x plus 13. Alright, try it on your own. Pause the video, come back, and see if your steps match mine. Step number 1, the A is 1, so we're good. Step number 2, I need to move the constant. Step number 3, the middle term divided by 2. Step 4 is to square it. Step 5 is to add it to both sides. Step 6 is to come up with a perfect square. Step 7 is to square root both sides. Remember, when you square root a negative, it's imaginary, and square root of 9 is 3. And then step 8 is to solve, so 2 plus minus 3i. You can come up with whole numbers, you can come up with fractions, you can come up with radicals, you can come up with imaginaries. Everything is possible when you complete the square. So that is completing the square for its solving purposes. Its main purpose, however, and this is going to become really, really relevant in next year, and actually in the last part of the homework on page 287, the 73 to 82, the ones that are going to be assigned in class. Why do we have to complete the square? The main reason that we are going to be doing complete the square is because we want to be able to change from our general form, which we know as ax squared plus bx plus c, to vertex form. And that vertex form is y equals ax minus h squared plus k. That's going to be the biggest reason that we do complete the square. It is, of course, a way to solve it, but one of the biggest things is we're going to be able to switch from one form to the other. So we're going to practice that a couple of times. Here I have y equals x squared minus 16x plus 2. And the steps are going to be extremely close to one another, but not completely. So the first thing that we're going to do is we're going to kind of leave this left side alone where the y is. So instead of moving the constant over, what we're going to do is we're just going to separate it off. We're going to go x squared minus 16x. We're going to leave a space. We're going to leave a space. And we're going to put the constant. Okay? So then we're going to follow our steps, and we're going to take the middle divided by 2, square it, and when we add it, we're going to add it inside, but we're going to subtract outside. So we're going to add inside and subtract outside. So plus 64 minus 64. All right. Now we still get a perfect square. Again, that comes from our division by 2. And we still have our numbers out here, so minus 62. And there's our vertex form. Our vertex which we talked about here just a second ago, y equals a x minus h squared plus k. The vertex is the h and k of the equation. H is always the opposite sign of my equation. K is the same sign. So if I ask what is the vertex, you would say it is 8, negative 62. Opposite sign, same sign. Okay, so let's try this again. Y equals 2x squared plus 12x minus 5. Okay, so we're going to kind of ignore this y. We're going to separate off 2x squared, 12x. And we're going to, we know that this, eventually we're going to plus something in here, and we're going to minus something out there. And then the negative 5. The problem with this one is that there's an a. And this is completing the square because that's the process we're following. And when we're completing the square, we can't have that a. So what we really need to do is we need to take the 2 out. And if I divide the 2 out of this, that means whatever I'm subtracting, I have to multiply it back in. Because I have to undo. Out here is the undo of whatever I do here. That's how we keep it balanced. That's how we keep it equal. Alright, so we take our middle term, divide by 2, we square it, and that's what we're going to put in to those locations. So this one gets a 9. And then we have still this minus 5 out there. Okay, so here we have 2. This becomes a perfect square. This is minus 18 minus 5, so that's minus 23. So now what is the vertex? Well, the vertex is the opposite, so negative 3, and the same, negative 23. Try it again. Y equals negative x squared plus 4x minus 1. If you can, pause the video, try to work it out on your own, and see if you can come up with it. So the first thing we want to do is we want to separate off. Knowing that we're going to fill in these 2 spaces, one of them's added, one of them is subtracted. But because there's this a, I got to take that negative 1 out first. So that means that's going to become x squared minus 4x. And that means I'm got to multiply whatever that is out there. Okay, so take the middle term, divide it by 2, square it, and that's what's going to go into those locations. All right, so this gives me a perfect square of x minus 2. This one now says positive 4. So I get y equals, you don't write negative 1 as a coefficient, x minus 2 squared plus 3. What is the vertex? Opposite inside, so positive 2, same side, sign outside, 2, positive 3. All right, last one, again, try it on your own. See if you can get it. Otherwise, go ahead and continue, and I'm going to walk through the steps. We're going to separate off the variables, leaving the 2 spaces. We can't have a 2, so we're going to take out the 2 from both of my terms. Yes, it leaves a fraction. Yes, it's ugly. And we're going to, we divided it out of the front part, which means we're multiplying it into the second part. The middle term divided by 2, 3/2 divided by 2 is 3/4. When I square that, I get 9/16. So I get 2 x plus 3/4 squared. And then this 9/16 over here is actually negative 9/8 plus 1, which is 8/8, so minus 1/8. And that's all the farther we can go. Y equals 2, x plus 3/4 squared minus 1/8. So what's our vertex? Opposite sign and same sign. Negative 3/4 and negative 1/8. All right, again, these are the ones you're going to do on the last one, 73 to 82, and it is the main reason that we do complete the square.